So computers awful slow today. I'm not sure what's going on. Has something to do with Trump winning. What? Okay. What was it called? First derivative test. There it is. All right. So the idea on the back, turn it over to the back page. So the bottom line is, okay, so this is called the first derivative test. The first derivative test. Now, test, what does that mean? Test for what? The reason it's called the first derivative test is we're using the first derivative to test for local max and local min. That's what the first derivative test is. Okay? So if you want to get your books out here and look at the top of page 58 is kind of where I'm interested in as we're looking at this worksheet. Top of page 58. And so we've got, if we think about the first thing we did with that little activity, we were focused on what? We were focused on what connection between F prime and F? Well, not the switching part, but even before that. That's what the worksheet was about. But even before that, that first activity we did, that Desmos thing. What were we focused on? About F prime and F. The what? Yeah, but yeah, what relation? The slopes, right? Okay, increasing. So let's put that into words. Now, what are we talking? Slopes, what? Increasing what? What do you mean?
F increases the F prime graph is positive.
There you go, right there. That was the big one, right? We're saying when F prime is positive, F is increasing. Now, we said the other way around. If F's increasing, F prime is positive or greater than or equal to 0, right? It could be flat, but so it could be increasing, flat, and increasing again. But bottom line is basically the key is if F prime is positive, F's increasing, right? If F prime is positive, F's increasing, and then vice versa. Or the other situation would be if F prime is negative, F is decreasing, right? We didn't say anything about F prime increasing, though, right? We didn't say anything about F prime increasing, right, yet. We've said if F prime is positive, F's increasing. If F prime is negative, F's decreasing, right? Because that's just slope, right? Okay, so those are the first two basic pieces of information got to have down cold. Okay, then we went to this activity. This activity now, Jesse, this activity is talking about the switching. Okay, this activity is saying, and your conclusion there at the end is, let's look specifically at this point at -8 and at this point right here. What happened at those 2 points about F prime? Look at your sign change on your table on the back at -8 and at -2. What did you have? Isn't that the only 2 times it did that? On that back, isn't that the only 2 times that F prime switched from positive to negative? Okay, so if F prime goes positive to negative, then what do we have on F? What are these 2 points called right here? Local max. Okay, that is part of 1/2 of the first derivative test. The first derivative test says that at a stationary point, or let's say at a critical point, now what was a critical point again? Where what was 0? Don't say it.
Slope is either 0 or
yeah, let's use F prime, but that's the same thing, right? F prime, where it's 0, right? What are we talking about? Where F prime is 0 or undefined. If F prime is 0, so if we have a critical point, and remember we said that could be a local max, could be a local min, could be a flat spot, right? Could be a vertical tangent, could be a lot of those things. So and we can go back to that slide, but we said if we have a critical point, let me put it up here. If we have a critical point, F prime is 0 or undefined, Then we said that could be a local max, that the slope is 0, it could be a local min, slope is 0, we could be a flat spot, slope is 0, could be that, slope is undefined, could be that, vertical tangent, slope is undefined, right? So we get a critical point to be one of those different things like that, right? If we have a critical point, what has to happen for it to be a local max? To be a local max, the slope has to change from positive to negative. That makes sense. It means it has to go up, F. See, I said it. You should catch me on that. F has to go up, then down. I mean, come on. How easy is that, right? What has to happen at a local max? A local max, the graph has to go up and then go down. That means its slope has to be positive and then switch to negative, right? F prime has to have a sign change. That's the first derivative test. Now, when's that going to happen? It's going to happen when the slope is either 0 or undefined, right? When the slope is either 0 or undefined, it's got to switch, right? If you're counting and you're going to go from the positive to the negative, you're counting backwards, aren't you going to have to go through 0, right? Where does it switch from positive to negative? At 0, right? So F prime is switching from positive to negative. It makes sense it would happen where it's 0. But it could also happen where it's undefined, too. Okay? All right. And then for a local min, where are the local mins on this picture? Here's a local min. Here's a local min. What happens at local mins? F prime switches from negative to positive. So F has a local min. So that is the other half of the first derivative test. So what happens is, if we want to know if we have a local max or local min, we first, step 1, see if it's a critical point. Is the derivative 0 or derivative undefined? Because if the derivative is not 0 or undefined, we're not going to have a local max. If the slope is 2, it's not going to be a max, right? Because it's going to be like this. It's got to be at a peak. So if the slope is 2 or the slope is negative 2, we're not going to have a local max or min then, right? The slope, so we first see if we've got a critical point, and if we do have a critical point, the way we test to see if it's a local max or local min is we see if F prime changes. Now, if we have a graph, we don't have to worry about that. We just look at it, right? I mean, some of you are probably saying, what's the big deal about this? If you look at a graph, I'll tell you right where the local maxes are, right? They're the ones that have a peak, and the local mins. But we're not always going to have a graph. We're going to have an equation, right? We're going to have an equation. And if we have an equation, and we don't have our calculators to use, how can we tell on an equation if it's got a local max or local min? This is what we're going to do. Okay, this is what we're going to look at. Okay? All right. And then, of course, then you had some other spots, right? You had these, I don't know, let's use this green. I never use that. What do we have right there? What do we have right there? Those are critical points, right? Slope is 0 there, slope is 0 there. Or excuse me, slope is undefined right there. What's happening at those points? But what's happening to F prime? There's no sign change, right? What you have here is positive slopes, then they're 0, but then they go back to positive, right? That's possible. You could count down 3, 2, 1, 0, 1, 2, 3, right? It doesn't have to switch from positive to negative, right? You could hit 0 and then stay positive. So there's no sign change. No sign change, no local max or min. Flat spot. Here, you've got negative slopes, undefined slope, and then negative slopes again. Again, no sign change. So there's no sign change, there's no local max or min. So the first derivative test is a way of finding the local max or min. So if we go to page 58, might not be a bad thing to put in your notes. So basically, first derivative, oops, that's not good. First derivative test for local max / min. Okay? The first derivative test for local max / min is if x equals a is a critical point of f of x. Okay, so that some people asked yesterday, what's that x equals a thing? What are you saying? If x equals a is a critical point, so that means either the slope is 0 or undefined, so that's key. We got to have that first. So the first thing is we look for our critical points. Where's the derivative 0? Where's it undefined? Okay, I think I told you guys this earlier. A lot of times this year, you get stuck on a problem. I'm going to say to you, well, if you don't know what to do the derivative and set it equal to 0. Right? Do the derivative and set it equal to 0, because finding the stationary point, right? Stationary point's where the derivative is 0. Finding the stationary point can be a good start because something interesting usually happens at a stationary point, right? So that's the key to this. So if we know we've got a critical point, right? Derivative 0 or undefined. Stationary points, remember, are a subset of that. They're the ones where derivative is 0. So if we have a critical point of f of x, then if f prime changes, I'm just going to say it this way, from positive to negative at x equals a, then x equals a is a local max of f. Okay? So if f prime, so what does that mean you have to do? You have to be able to look on the left and the right, right? You have to be able to see what the slope is on the left and see what the slope is on the right. And then you know you've got a local max point. If f prime changes from negative to positive at x equals a, then x equals a is a local min of f. Okay, so what that tells us is we can just look at f prime and tell if f is a local max or a local min. So let's take that information and let's go to this graph right here, and we'll take a look at it. We'll talk about the homework here in a second. So that's the worksheet. That's what the worksheet was about. Okay, that's what the worksheet was about. All right, the first derivative test. How we tell if we have local max min. So let's pretend, just pretend for a second you can't see this graph here on the left. Okay, just pretend we cannot see this graph over here. All right, all we have is the f prime graph. Right, all we have is the f prime graph. And we would like to look at the f prime graph and see what's going on. Now, we said yesterday if f prime is negative, then what? Then f is decreasing, right? If f prime is negative, f is decreasing. So if I'm looking at the f prime graph, where is f prime negative? Where it is where? Below the x-axis, right? Right here is where f prime is negative. Everybody agree with that? Right? So we gotta be real clear on this. So when I say where is f prime negative, you would say when it's below the x-axis between a prime and c prime, right? What is the f? Now let's look at the f graph over there. What's the f graph doing between a and c? Decreasing, right? That's what you just said. So we know just by looking at this graph right through here that the f graph is going down, right? That's all we know from that, but it's going down. Okay. Now, where's the f? The other thing we said yesterday, when f prime is positive, what? F is increasing. So this graph is positive up until a prime, right? It's above the x-axis. Sure enough, this graph's increasing until there. And it's above the x-axis after c prime, which of course is right there. Okay, so that's what we said yesterday. Now we got this first derivative test. First derivative test says if you have a critical point, which is where the derivative is 0 or undefined. So here's f prime. Where's it 0? At a prime and c prime, right? So we're going to look at the x-axis. That's going to be a big deal for us this year. When we see an f prime graph, a lot of times we're going to focus right in at the x-axis. First place we're going to look. Because think what we're talking about. A stationary point where the derivative is 0. On a graph, 0 is the x-axis. So f prime is 0 right here and here. So we're going to be real interested in those points. Now, what we know then at those points is that we got one of these three situations on f, right? We got one of these three situations. If f prime is 0, not these, because this is where it's undefined. We've got one of these three situations. Now, which one is it? Well, that's where the first derivative test comes in. What happens at a prime? You'll see me do this a lot on an f prime graph right there, right? When that crosses through F prime, what you just wrote on this last page? You wrote, if F prime changes from positive to negative at x equals A, then x equals A is a local max of F. Well, that's what's happening right here. At A prime, F prime is changing from positive to negative. So there's going to be a local max on F, and sure enough, boom, there it is. Right? And vice versa, what's happening here? F prime is changing from negative to positive, so therefore we've got a local min. F is decreasing and then increasing, we got a local min. Okay? One of our goals here in a little while is going to be have an F prime graph and be able to sketch the F graph from that information. So think about all that information we just had there about it going up, going down, local maxes, local mins, right? We got all that so far.
The local maxes, the local mins of the F prime graph function points.
Okay, now there's more stuff going on here, isn't there? Right? Because you've got this point, which seems to correspond to that point, right? And we also have the concavity. We know it's increasing, but how do we know it's concave up, down, that kind of stuff? Right. So I think you are right. There is some stuff going on here, right? There's some extra stuff. So I'm kind of taking it slow with that, but we're going to list that out here in a bit because there's a lot of stuff and it's easy to get confused. But you are exactly right. That's what's going on. Okay? So let's go to the homework. So the homework questions on 16 through 20, was there any questions on the earlier ones? 7, local max and global max. Where global max is the highest value, right? Global max is where the highest value happens. So on this one, the global max would be here, right? The global max would be here. But these are both local maxes. And there would be no global min. If you assume that there's an arrow here and it goes down forever, we'd say there is no global min. If we're only going to look in this window, then we might say the global min would be this value, whatever it is down here. Right? If we're going to look at a closed interval and say, let's just look in this window and stop this graph right here, then this would be our global min. So sometimes the global max or min's at an endpoint, and it isn't a peak kind of thing. It's just the lowest point, and it might be down at an endpoint. We'll talk more about global max and min later. Right now, we're just going to focus on local max and min. Okay? And then what else? 16 through 20, that was about it, wasn't it? What was, 10. What's the relationship between stationary point? Oh, well, that's the first derivative test. That's what we said. What's the relationship between stationary point and local max and min values? Extrema. So that's a term you're going to hear. Local extrema is just a way of saying local max or local min. Right? Extrema means extreme points. So when it switches, so at a stationary point, you could have a local max or local min. It depends on if F prime changes from positive to negative or negative to positive, right? If that question was on the quiz, I would want you to write a little bit about that. What's the relationship between stationary points and a function's extreme values? The stationary points are the places where the extreme values can happen, but for there to be a local max, F prime has to change from positive to negative, or to be a local min, F prime has to change from negative to positive. Right? So those are possible locations of local max and local min. But it could be a flat spot, right? It could be a flat spot, okay? So that's why we have this first derivative test. Just because the derivative is 0, we don't know which one of these 3 we have, right? So we got to look more, look into it more closely. All right, so on 16 through 20, again, hopefully this was very simple, but this is the F graph, and it's very important that you always identify that first. And then, where is F prime positive? At which points? A and D, because that's where F is increasing. Simple, simple. Between which pairs do we have stationary points? Right there, between A and B. And right there between C and D. Stationary points, where's the derivative 0, right? With these terms, we're just practicing these terms. Got to make sure we know. Where is there an inflection point? Between B and C, right there. Between where is F? Okay, so now we get into kind of what Will's talking about. I've been kind of purposely steering away from this, just not to add too much confusion. Where is F prime increasing? Not between B and C. No, it would be after D, I would agree. but not before A. Anybody else? Between C and D. Why? It's also after D too, to be honest with you, but they said between which pair of points. So C and D would be the answer. But why? But what about right after C? If you're going to say between C and D, what about right here? Does it have to do with concave? Let's talk about this a minute. Let's just write down the slopes. Hey, let's do this. And this is good because this is a good lead-in for what we're about to do here. Give me a guess at what the slope is right here. Give me a number. 4. I like it. What's the slope right here?
4.
Ah, see, I disagree. I don't think it's getting steeper. Isn't it getting less steep? Now, I'm assuming the inflection point's back here. Isn't the inflection point where it's the steepest? Doesn't that make sense? Inflection point is steep. So I'm going to assume the inflection point is back here. Now, maybe not. Maybe not. Maybe I should. It's kind of hard to tell. Does this seem like it's concave down this whole time? Let's just start here. So let's say that's 4. What's this? Okay. I don't want to get that picky. Let's call it 2. What's that? 1. What's this? 0. These are the slopes now I'm writing, right? These are the F primes I'm writing right now, right? Because this is the F graph. Okay, what's this? -1. -2. Right here's our inflection point. -3. What's right here? Okay, now it's not as steep, right? -2. -1. 0. 1. Where, right? Why is that? Because inflection point is where it changes concavity. So this is concave down until right in there somewhere, and then it switches to concave up. Okay, now what can you tell me about F prime? What can you tell me about those F prime numbers? They go 4, 2, 1, 0, -1, -2, -3. What can you tell me about that string of numbers? Aren't they decreasing? But now it gets confusing here because when you get into negatives and you talk about them decreasing, they actually are getting steeper, right? Positive, so here's what I usually say. The slopes are positive and getting less positive. Isn't that decreasing? Think about a graph that's decreasing. 4, 3, 2, 1, 0, right? It's positive getting less positive. Then once you get past the x-axis, sorry, whoever is watching while I'm recording this. Positive and getting less positive is decreasing. But then what happens when it gets here? It's negative and getting, well, no. Okay, I get what you're saying. But these values are negative and getting more negative. I don't even know if that's a real term. That's just, I made that up, I think. I don't even know if more negative means anything. But to me, it makes sense. -1, -2, -3, -4 is getting more negative. Right? To me, that's decreasing. So whenever I think of decreasing, I always have to remind myself there's 2 types of decreasing. There's positive and getting less positive, 4, 3, 2, 1. And there's negative and getting more negative, right? -1, -2, -3, -4. That's also decreasing, right? So that's what these slopes are doing. But look what's happening that whole time. The graph of F is, what's the graph of F this whole time? Concave down. Because what I have are positive slopes that are getting less positive, and then I turn to negative slopes that are getting more negative. Doesn't that have to make concave down? So didn't we just understand right there that when F prime is decreasing, doesn't F seem to be concave down? Isn't that what seems to be happening? So now back to their question. What's happening when F prime's increasing? Well, let's go after that inflection point. What are the slopes? The slopes are -3, -2, -1, 0, 1, 2, 3. What do you tell me about that string of numbers? That string of numbers is increasing, right? F prime is increasing. Now, what's increasing look like? Well, let's go the other way with this little graph here. This graph is increasing. These values are negative and getting less negative. -3, -2, -1, right? And then switching to positive and getting more positive. So what that means is you got slopes that are negative, but getting less negative. So you get slopes that are like -4, -3, -2, -1, right? But then they switch to positive and getting more positive. Doesn't that make concave up? That's what makes concave up. Negative slopes that are getting less steep, and then positive slopes that are getting more steep. What you get are these increasing numbers. So what we just learned from that is if F prime is increasing, then F seems to be concave up. And then, Will, that takes us to your point. So let's go back to this graph here. Then look at the F prime graph. What do we have happening? We have F prime decreasing, right? F prime is decreasing to here, which we just said means F is what? See why I've been going slow with this? It's hard to keep track of all this. What did you just write down? When F prime is decreasing, F is concave down. When F prime is increasing, F is concave up. So, Will, you said when F prime has a local minimum is at an inflection point. Well, think about it. If F prime is decreasing, then increasing, F prime has a local min. F changes from concave down to concave up, which is the definition of inflection point. Inflection point is where you have a change of concavity. So wouldn't a local max on F prime also be an inflection point then? Because you'd have F prime increasing then decreasing, which means F would be concave up, then switching to concave down, which would mean you'd have an inflection point. So, yes, a local max or a local min on F prime is going to mean an inflection point on F. So this is where we have to be real careful, because when we talk about F prime being positive, F is increasing. But we can also talk about F prime increasing, which tells us F is concave up, right? I mean, so the word increasing is used in both, but once it's with F, once it's with F prime. So we really got to make sure we keep those straight, okay? One is local max, local min, the other is inflection point. All right, so that, and I always come back to this whenever I have to think, whenever I've got a question like this that talks about F prime increasing, I'll be honest, I do this. I think to myself, F prime increasing, that's slopes. What happens if the slopes are increasing? Now, it's easiest to think about positives. If I think about slopes increasing, I just draw that for myself. I say, oh, yeah, that's concave up. But what about if they're negative? Well, this is the other way you can increase, right? You can be negative and get less negative, or you can get positive slopes and get more positive, right? That's increasing. So, -3, -2, -1, 1, 2, 3. That's increasing. So I think of this list of numbers like that, okay? So, it's a thing you're going to kind of memorize anyway. All right, so let's do this. Let's list out these connections that we've got here. Let's see, did I use? Yeah. Okay, let's list our connections. Let's make a list in our notes. Let's kind of organize our thoughts here a little bit. Okay? So we started with what fact about, yes?
Could you do an F prime graph of a piecewise function?
Sure.
Would the F prime graph also be a piecewise function?
Possibly. Yeah, probably. I mean, it depends what your pieces were. You know, I mean, you could make an F graph that was piecewise where the F prime graph probably would not be, would be smooth and connected. But generally speaking, that would be true, okay? generally speaking, when you switch from one graph to another, for example, the V graph. If you think of the V graph, and we kind of did that the other day. We kind of did that the other day when we were doing that position velocity acceleration. You know, you move away from the origin and then back, right? Well, the derivative graph of that was what? It was up here positive. Oh, wait, yeah. It was positive and then it switched. It went like that, right? So all of a sudden you have this graph, which is, you could say piecewise because it's a line switches to another line. And then this would be piecewise too. So a lot of times that happens. A lot of times that happens. All right. So let's start with what we were doing yesterday. So what's one thing we can figure out about f prime? F prime is what? Okay, let's do it the other way. Let's say f prime first.
F prime is positive.
So f prime positive, f increasing. Now we can write this out in full sentences, but there's no sense to do that right now. Okay, so if f prime is positive, f is increasing, right? Okay, let's do another. Vice versa. F prime negative, f decreasing. Okay? What's another one? Well, f prime can be positive, f prime can be negative. What else could f prime be? 0. Yeah, let's don't forget that one. That's probably a bigger one. That probably should be number 1. F prime equals 0. What can you tell me about f? Or flat spot. It's a local max, it's a local min, or it's a flat spot. Now, that's also I'm going to put off to the side, that's a stationary point. We want to make sure we understand that. F prime is 0, that's a stationary point. F is a local max, min, or flat spot. Okay? What else could F prime be? F prime can be undefined. Now, these two together are called what? Critical point. Okay, let's put that over there. So 3 and 4 together are called critical points. Okay? So F could be a local max, min, oops, I know I put a comma there. Could be a local max, min, really wouldn't be a flat spot. Could be a vertical, let's put sharp point, vertical tangent. Right? Could be a sharp point, could be a vertical tangent. Because a sharp point might not be a local max or min. I mean, you could have a graph come in here. You could have a graph come in here at a sharp point, like so, and then go curving, like it come in straight, right, like this, and then kind of curve out of there. That would still be a place where the slope could be possibly undefined, okay, where it might not be at a minimum, okay. So the slope could be undefined there. It could take a turn and not be a local max or min. So it's possible. So I would call that a flat spot, though, okay? Because a flat spot is where we're going to say that it's horizontal, so the slope is 0. So, but it could be a V, so it could be a local max or local min, and it wouldn't even have to be a V. I mean, it could come in like this, and then, like I said, it could curve, you know, like that. You know, you could have that kind of situation. So that'd still be a local max, local min, right? But it wouldn't be, I wouldn't call it a flat spot, right? So it could be a local max, local min, could be a sharp point, could be a vertical tangent, right? Different things. All right. 5. So those are the things f prime could be. Now, well, and then what did we just add here? We added if f prime is increasing. So if f prime is increasing, f is concave. Now, which one was it? For increasing, it was concave up. And if F prime is decreasing, F is concave down, right? So it's helpful, I think, to organize all this, all these different things. Now, what about the switching? Let's get into the switching parts, like the first derivative test. F prime goes positive to negative. F has local max. And of course, vice versa. F prime goes negative to positive. F has local min, right? So up to the side here, I'm going to write first derivative test. That's our first derivative test right there, right? Those two together are how we check to see if we have a local max or min. See if F prime changes from positive to negative. And then the last one would be the one Will said. Yeah, now F prime has a local min or max. F has an inflection point. And that's because, I might put in parentheses, because F prime changes, or no, we'll say goes. Changes is probably better. We probably should have said that up there instead of goes positive to negative. F prime goes increasing to decreasing or vice versa. Now notice with our first derivative test, it mattered. If F prime was positive then negative, we had a local max. If F prime negative to positive, we had a local min. So it depended which way it went. But with the inflection point, it doesn't matter, right? If F prime goes up then down, you've got increasing to decreasing, which means, okay, so look at 5 and 6 here. Look at 5 and 6. So if F prime goes up then down, right, local max, then you've got F changing concave up to concave down. Changing concavity, you got an inflection point, right? If you go the other way, if F prime goes down then up, you got a local min, and F goes from concave down to concave up. Again, you got to change the concavity, right? So an inflection point just needs a change in concavity. Doesn't matter if it changes, doesn't matter if it goes concave up to concave down or the other way around, right? So here we had to list two separate things. When F prime changed positive to negative, but when F prime changes increasing to decreasing, it doesn't matter which way it changes. It just means a concavity will change. So therefore, we've got that.
So those go from concave up to concave down, and then concave down.
Either way, you've got an inflection point, right? Because an inflection point is just where the graph changes concavity.
So like when it's increasing, it goes from.
When F prime's increasing, F is concave up.
Oh, it is.
So when F prime's increasing, F's concave up. So this is F prime, I'm drawing right here, right in the air. F prime is increasing, F is concave up. Then F prime changes to decreasing, so F is now concave down. So right here, you had a change of concavity. Okay? If you go the other way, decreasing, F is concave down, increasing, F's concave up. Again, you had to change the concavity either way. Now, 5 and 6, so the idea is 9 is related to 5 and 6. 9 is when you switch from one of these to the other, you've got to change the concavity, so you got a flex point. 5 and 6, or excuse me, 7 and 8, the first derivative test is like switching these two, right? When F prime is positive, F's increasing. Then when F prime is negative, F's decreasing, you got a local max, right? Got a local max. So anyway, so those are the things in no particular order that can happen with F prime that will tell us something about F. And that's about all that could be interesting about F prime, right? It's either positive or it's negative. It's either going up or it's going down. It might be zero. It might be undefined, right? And then it might be switching between those things. It might be switching from positive to negative. It might be switching from increasing to decreasing, right? So that's pretty much it. I mean, that's pretty much the things you could be doing. And they all tell us something about what F is doing. All right. So what I'd like you to do here is a little activity. So get your Chromebooks out. And
I've got a little sorting thing, little card sort for you to do. All right, so those of you listening at home should be able to get on to this, I think. I don't think it has to be. I think it can be gotten on any time. So student.desmos.com, ZM3SR, and it's right up here in the corner, ZM3SR up here, student.desmos.com. Look at that, Skylar's already in. I wonder if she did that last night, maybe.
Yeah, she's at your leadership.
Yeah, she's at the youth leadership party today, so. All right, so what you have, oh, look at that. She's got them all right. Green means she's got them right. Okay? But what you have, oh, wait, what the heck? That's not right. Huh. Well, okay. But for some reason it didn't save, I guess. Well, okay. Anyway, you're supposed to match, so each one of these is a pair. One is F, one is F prime. Now, I was going to give you a hint that all of the parabolas are F primes. I was going to make those blue, okay? And then the other ones are red. So all of the parabolas, there's 6 of them. How many total cards are there? Yeah, 12. 6, so all the parabolas are F prime. And they all match with one of the other graphs that's the F. So drag it on top of each other, the ones that go together. Okay, and I'll tell you how you're getting it. Then when you go to card 2, when you go to the next screen, it's the same thing. Now there's a lot more of them, right? There's 24 cards, there's 12 pairs. But the red is F. Red is F, and blue is F prime. Okay? I Skylar didn't get all those right.
Okay, well, I'll take that on the screen, so but I'll tell you.
Okay? So, everybody understand that then? So F is the red and F prime is the blue when you get to the second one. On the first one, F primes are the parabolas. Now, if you want to ask each other, help each other out at some point with that question, I'd rather you do that than ask me. Max, you got them on the first screen. Will, yours are right on the first screen. I don't know how updated. Emily, you've got one of them right now. Tricia, you got one right
Do the powers of
on
the
that first one.
F graph correlate to the power of the F prime graph?
I don't know.
Yes.
I don't know.
Do we have to actually look at the numbers?
What's that?
Do we have to actually like look at the numbers?
You gotta pay attention this way especially, right? I mean, because it's like we were saying, when you had on this, on this picture here, right? So if you were stacking on top of each other, this inflection point, this B point, see how it's just a little bit past the x-axis? And that corresponds to this point right here. So they have to line up. So this A, where this switch from positive to negative, that corresponds to the max here.
I didn't know that like exact point.
Well,
Like,
they're
they
not-
didn't give you B, how would you know that that's where it changed from the
Huh?
concave down?
Well, now remember, that one is the F graph, right?
Yeah, so like it's concave down right there, but how do you know like right there it's gonna?
Well, it's
switch?
roughly right around -2 or -3. So you're looking for a graph this is concave down and then concave up, right? Which means F needs to do what? If F goes concave down to concave up, F prime's got to be going down, then up. Right at about, it's got to be going down then up, right at about -3, -2 somewhere. So where's one that's going down then up? Here's going down then up, but way over here. This one's going down then up, right about where you want it to. This one's going down then up, but way over there. So it's got to be that, right? Yeah. Concave down. Yeah, there. So if this is F prime, it's negative, which means, so F prime is negative at first, right? So that means F has to be going down. So you're looking for a graph that's going down at first, right? So where's one that's going down at first? That one. That one. That one, right? But this is negative just to the left of the y-axis. So it's negative, so it's going down right until the x-axis, so that would be like this one's going down. This one's going down way over here to the left. So that, yeah, that looks like that. So that's what I do. I look at the parabolas. Because think about our list. Our list we made was about F prime. If F prime's doing this, then F has to do this, right? So I would look at the parabolas and see when they're negative, when they're below the x-axis, when they're above the x-axis. Everybody look up here a second. So let me just give you, now some of you are rolling right along and that's great. You may not totally agree with what I'm saying, but if I look at this, think about the list we made of F prime. We started with what? F prime positive or F prime negative, right? So if I'm looking at this F prime graph, the first thing I would say to myself is F prime is positive, then negative, then positive, right? Think about that. If F prime is positive, then negative, then positive, what's F got to do? If F prime is positive, negative, then positive, what's F got to do? It's got to up, down, up. Now, you can get into concave then if you want. You can say, well, this is decreasing, and so this is concave down. But I don't think you need that, to be honest with you. I think you can get most of your stuff if you just think of the positive and negative and increasing, decreasing. If this goes positive, negative, positive, then you know F's got to go up, then down, then up. So you're looking for a graph like that. And then it's got to do it at the places that, match up. Okay? But you're looking for a graph that goes up, then down, then up. So that's what I would look at if I was looking at an F prime graph. I would also look at these zeros, these stationary points, and that's where we talk about positive, negative. That's going to be a max, that's going to be a min, right? That's what I would be looking for.
Extra blue.
The what?
There's extra blue.
What? No, there's not.
I have 4 red and 6 blue.
Okay, well then you're not seeing them all or something.
I have all
I was going to say, unless you put 3 cards together, which I don't know that it'll let you.
It does.
Will it let you put 3? Yeah, so there's so many cards, you got to be careful you don't overlap some. Yeah, here's where you are right now, if you want to look. All right. We need to move on to something here, but that's okay. I know you're right in the middle of thinking about it. I hate to cut you off, but we got to talk about something else here. And that's okay because that can be part of your assignment. And it's not all bad to have to come back to this later and, after some time away and then get to think about it, and finishing them up, the ones you don't have. So you can come back into that. Okay. So that will be part of our assignment will be to try to get that. Now I'm not gonna dock you if you got them all wrong or anything. But again, the point of that is to be able to do that because we want to be able to, like on a quiz, I might give you 2 graphs and ask you which one of these is F and which one is F prime, or we'll have several of those in our homework here over the next couple of days. Okay, here's what I would like to do is, this again is an invention of mine that I call the chart. And this is a very creative, inspirational name, but if you ask former calculus students about the chart, they probably can draw it up for you. We will talk a lot about the chart as we go throughout the year. And this is just my attempt to take what we wrote here and put it in a more memorable form, a more usable form. Okay? So, make kind of a box here. Now you're gonna redraw this several times probably, so it doesn't have to be real fancy. we're gonna make this, right now, we're just gonna make it 2 rows. Okay, this is gonna be F, this is gonna be F prime. Now, eventually, we'll add F double prime down to the bottom. Okay, so we'll have a third row on our chart. And on our next quiz, on the no calculator part of the quiz, what is very common is when I hand it out, when you get the no calculator part of the quiz, what a lot of you will do is you'll quickly write this chart at the top of your page. I mean, you don't have to, but that seems to be what people do many times. They just jot down this chart from memory. Okay, it's pretty easy to create. And what we're going to do is we're just going to take all of these things and we're going to put it in. Okay, so we're going to start with, in the first column of here, we're going to put a 0. Okay, so we're going a little out of order of the way we wrote it. But if F prime is 0, what's that tell you about F? I usually write this in. It's a stationary point, and that's either a local max, a local min, or a flat spot. Now, for right now, I'm not going to put in F prime undefined in the chart, but that kind of goes along with that. It could be, again, this could be a sharp point. You know, you could have a sharp point, but again, it could be a local max or local min. So it's kind of the same scenario, right? F prime undefined. But we're going to mostly not deal with that on our next quiz. It's mostly going to be about stationary points. It's mostly going to be about where the derivative is 0. Undefined is probably going to come up later on more likely. Okay? All right, what's the next thing F prime could be? Give me one. F prime positive. Okay, that's a good one to go next. F is increasing. F prime negative. F is decreasing. Okay? Now, if we switch between those two columns, if F prime switches from positive to negative, what do you got? Well, you got F going up, then down. What is F if it goes up, then down? Local max. Or if you go switch the other way, if F prime goes negative to positive, then F is down to up, which is a local minimum. So when you switch these two columns is when you get your local min or local max. This is your first derivative test right here. This is how you tell that you have a local min or max, is when you switch between those two columns. All right, what else could F prime be? So we just took care of that one, that one, that one. We're not going to do that one, and we just did that one and that one, right? We just took care of all those in those first 3 spots, and we talked about switching columns, right? So what else could F prime be?
Increasing.
F prime could be increasing, which tells you that F is concave up, and F prime could be decreasing, which tells you that F is concave down, right? And if you switch these two columns, what do you got? You got an inflection point. If you switch these two columns, you got an inflection point. If F prime goes from here to here, or here to here, then you've got F switching concavity. Therefore, you've got an inflection. So there you go. That encompasses everything we just had in that list of connections, right? And so, if you can recreate that chart, think how easy that is. All you got to do is you start on the F prime row. F prime could be 0, F prime could be positive, F prime can be negative, F prime can go up, F prime can go down. And then you know they're easy. F prime's positive, oh, slope's positive, graph's going up. Slope's negative, graph's going down. And then here, everything left's concave up, concave down. I mean, it's not hard to memorize that. And then when you have that in front of you, and now you can think about it. So when you're doing that matching thing, and you're looking at an F prime graph, you're looking at an F prime graph that does this, right? You're looking at an F prime graph that does this. You say to yourself, okay, well, where's F prime 0? Oh, right there and there, right? What's F prime doing here? It's positive then negative. Positive then negative, right? So if F prime is positive then negative, what do you have to have? F's got to be going up then down. Oh, I'm looking for a graph that's going up then down. What happens here? F prime is negative then positive. Negative then positive on F prime. F's got to go down then up. So now here it's got to go down then up. Oh, okay, I must be looking at an F graph that does this. Now, well, I'm assuming you were talking about this when you were talking about powers. You were noticing the F primes were all squares and the F's were all cubes, right? Was that kind of the thought you had? That's definitely a factor. That's definitely a relationship that is true, okay? So, and for simple polynomials, you could think like that. But for right now, I think you're better off, because then you get some in this second one that aren't necessarily those. So you do have to think more about it. But but think about this. If you're looking at an F prime, look at these things. Look when F prime is 0. Look on the graph where F prime's positive and where it's negative. Look, and then I notice I didn't even talk about increasing, decreasing, but I could. Right here, F prime is decreasing all the way to here. So therefore, F prime decreasing is F concave down. Look at this graph, concave down all the way to there. Then this graph's increasing, F prime increasing means F's concave up. Here it is. But I didn't need to look at all those things. Most of them just kind of came together. All right, so let's do this. So on your paper, if you would, in your notes, draw. This is one of the things that people sometimes find tricky. So we're going to do one together here. So if you would just sketch that out in your notes. I've got an F prime graph over there on the left. You're going to have one of these in your homework as well. Got an F prime graph over there on the left, and you are now going to draw an F graph. Okay? Doesn't matter how fancy you make this thing, just make that F prime graph kind of have that general shape. If I had room here on my screen, I would have put these, I would have put it under it, to be honest with you. If I was you, I would probably put my F graph under my F prime graph, because then you can kind of match your X's, you know. You can line things up a little nicer, but I didn't really have room. I have more room sideways than I do up and down, so I did it this way. But okay. Now, and to be honest, before you do that, you guys could just draw it right over top on the same graph too. I don't care. You could draw it right over the top of it, right? We could draw the F prime graph right over top of it. Okay. Matter of fact, I might do that, even though I have that. Even though I have that, I've made that extra axis. I think I'm just going to draw it right on top. So either way, it doesn't matter. Okay. Nice thing is I have different colors, right? So I can use a different color. So for you guys, it might not be as nice unless you do one in pencil, or you have different color. It'd be nice, but that's probably the only way it gets kind of confusing. Is if you have two graphs on top of each other. All right, so if I'm going to draw this F graph, starting on the left side, I mean, I can start identifying some things, but I actually have to draw it. So I need to kind of draw from the left to the right. But I could identify some things if I want to. Like, for example, let's start with the positive and negative. This F graph, this is the F prime graph, remember. This is negative, then it's positive, then it stays positive, then it's negative. I always think that's a good place to start with when I have an F prime. Negative, that's the first thing we learned about F prime, wasn't it? I did that for a reason. We spent a whole day just mostly talking about F prime negative, F prime positive, because I knew that we were going to add this other stuff and it gets confusing. So I always go back to that as my home base kind of. When is F prime 0, which is where it crosses here, and then also where is it, well, look what you got. You got F prime going negative to positive. What happens when F prime goes negative to positive? When F prime goes negative to positive, isn't that a local min? Because F is going to be going down then up. So I got a local min. What do I got here when it's positive and then stays positive? Flat spot, right? Because right here the slope is 0. But it's positive and then stays positive. So what happens is I got a flat spot. What happens here? F prime goes positive to negative. Local max. You see what I mean? So before I start drawing this, I start thinking about what these things are telling me. So just putting this stuff in here, these little blue plus minus, I think tells me a lot about what's going on. Okay? So now let's start on the left. So now I notice, now what I'm going to look at is actually my y values. Right here, I've got a negative 2y value, right? Which tells me my F graph has what? A slope of negative 2. So it's going to be going down and fairly steeply here at the start, right? Now the question is, where do I start my F graph? Doesn't matter. We don't know. It could be, remember when we talked about if you took an F graph and you plotted its slopes and then you took that same F graph and shifted it up 10, do you change any of the slopes? This F prime graph could represent an infinite number of F graphs. They would all look exactly the same though. They would all just be shifts of one another. Does that make sense? You take the graph and you plot its slopes and then you shift that graph and then plot those slopes and then shift that graph and plot those slopes, you would always get the same F prime graph, right? Because they all have all those graphs all have the same slopes. Okay, so great. So if we have an F prime graph and we want to draw F, we don't know where to start it, but since it's going to go down first, I'm going to start it up a little bit, right? Now, the other thing you could say is this graph is positive. The F prime graph is positive a lot of the time, which means F's going to be what? Increasing a lot of the time. So then you might think, well, maybe I better start it down if it's going to be increasing a lot, right? So I don't run out of room, right? So you could do that. Whatever. I don't care. I'm going to start it right here. So this graph is going to go down, okay? So it's going to have a slope of negative 2 to start, so that's pretty steep. But then what are these y values? Well, yes, but they're negative but getting less negative. So what's my graph going to do? It's going to bottom out. Well, didn't we just say there was a local min here? See, it's hard to keep track of it all, so you got to go kind of slow. So it's going to start with a negative 2 slope, but it's going to bottom out. I don't know where. Let's bottom it. I want to get it down below there at that point. So let's bottom it out right there. I don't know where it would bottom out for sure, but it's a negative 2 slope, and then it's, right? So it's concave up. Oh, yeah, it should. Now, we don't have to think about this, but remember, when F prime is increasing, F's concave up. So this should be concave up right here. But it's bottoming out. Okay, now it switches to, F prime switches to positive slopes, which means this is going up until, say, right there. I don't know. I'm just making it. I don't know where it is exactly. I don't know if it's right there, right? But it's until here. Now, what has to happen here, Will? You said this earlier. That's got to be an inflection point, isn't it? Because these slopes are positive and getting more positive, so that means this is getting steeper, steeper, steeper. But now they change to being positive and less positive. So the graph's still going up, right? Still going up until here, but they're getting less positive because these are positive slopes. So the graph of F still has to be increasing, but they're getting less positive till here. Now we have a 0 slope right here. So it has to flatten out. Now, what did we say was going to happen here? because we planned ahead here a little bit. What did we say was going to happen here? We said that was going to be a flat spot, right? Because what's happening now, these are positive values, so that means this graph's got to go back up again. So these are positive and getting more positive till here. So this graph's going up, 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 till here. And then what happens there? That's got to be an inflection point, doesn't it? Because positive and getting more positive, now they're positive and getting less positive. So that means F is still going up because it's still, F prime is still positive this whole time, so F has to be increasing. So see how all the way from 2 here, F prime was positive that whole time, so this graph has to be going up that whole time, but it did flatten out right here at this flat spot. Now what do we have here? F prime goes positive to negative. F prime goes positive to negative. What's F? Local max. F prime is positive to negative. F has to be going up then down. Well, it's already going up, so now we're going to negative slope, so this graph has to go back down, and there it is. So that blue graph would be a decent representation of F. Now, I don't know how far exactly. I don't know if it came down here farther before it bottomed out or it bottomed out right here, right? But it's that general idea. It's that general shape. But that F graph could have been anywhere shifted, right, and still been the same. Okay, now, we're going to be out of time here, but I'm just going to comment. This is number 50. You don't write this down, but this is like one in your homework. I think you have number 51 to do. 50 just gives you the equation. Tells you to draw the F graph. Well, all you have to do is plot it, graph it, okay? So they gave me this equation in 50, so I went ahead and graphed it. So now it's just like the one we just did. So now I have an F prime graph. Now I'm supposed to draw the F graph, right? So you're going to have that in number 51. So there's the homework. That's on this sheet, okay? So it says those problems, and then it says first derivative matching activity, which is that Desmos activity, right? So finish that Desmos activity and do those problems there. But on 51, and I think 46 might be the same thing, where, yeah, 46... No, 46 they give you an F graph. So graph it on your calculator if you want to. It's an easy one. You can just draw it on your paper too. Probably should draw on your paper. And then they're good. So that's an F graph on 46. On 51 they give you an F prime graph. So graph that on your calculator, then put it on your paper like I just showed you there. That's your F prime graph. Then you're supposed to draw the F graph. Okay? And I don't know. I thought there was one other one. Yeah, they do give you an F prime graph on 36, and I think you have to, do you have to graph it? Maybe. Oh, it's 24, I think. Yeah. One of those they give you, another one they give you an F prime graph, they want you to draw the F graph. So, all right. This one's a little longer. You're going to have to work a little harder on this side.
I watched it 12 straight hours.
For how long?
12 hours. Like 3:40 to 3:40.
You stayed up that late? Jeez. I went to bed. It was about 11. We had pair teach graphs. It was a long day. So.
Either way, we're screwed, so I might as well go to bed now.
What's that?
Either way, we're screwed.
Might as well go to bed. Well, when he won Wisconsin, I was about 11 or so. When they said he won Wisconsin, it was over. I mean, at that point.
It was
that point
weird, like the electoral college hadn't given up Wisconsin, but they gave him Pennsylvania. So Fox News was backwards.
Well, it depends on what channel, because one channel gave Wisconsin.
I was watching MSNBC and Fox News at the same time.
And they had
Trump at 248. I'm sure nobody won.
Well, and what about is a popular vote over? Because when I went to bed, she was ahead in that.
Up 100. It's 48 to 48%. She's up 100,000.
Oh, that's not very much.
Yeah.
All the votes are technically in, but they haven't.
But it's really close. Is it really close on the popular vote?
I think so, yeah.
I'd like more
Okay.
Last night when I'm just looking at the polls,
all of a sudden like,
ridiculously easy.
he's gonna win.
It was. It took me like 5 minutes.
Yeah, that was, no, it will definitely be not as easy. And remember, I just got to tell them, yeah, you have more work to do. Yeah, that was awful, but that's okay.
Yes.
Oh my gosh.
It's a lot problem.
Everything else.
Yeah, I probably should.
I can't believe one Thursday.
I know, it's the first time in 28 years.
What's that?
Trump won Pennsylvania.
Oh, that a Republican, well, yeah, right.
What did you get for the?
Did he end up winning Michigan or not? He won Wisconsin, Pennsylvania, that's all he needed.
Yeah, once, that's what I said, I went to bed at 11:30, once he won Wisconsin, it was over.
Well, I thought CNN was sandbagging. He was like up 40 and then
When you go to
not
second.
Did you get 1.2 kilograms?
Yeah.
Very good, buddy.
What'd you get?
Yes.
That must be so much
For what? I was so small. I was so
I think, yeah, I got
like 1.2.
Like very
So you guys
small.
Good buddy. I was, I'm pretty stupid.
I did that on my